Good morning, everyone. In our last session, we explored the concept of circular permutation. So, working through 4 to 5 examples to solidify our understanding of arrangement elements in a circle. So, circular permutation presented some unique challenges compared to linear permutation, and I hope you find the examples helpful. So today we are shifting our focus on permutation to combinations. So while permutations emphasizes the arrangement of order of elements, combinations are concerned with the selection without regards to order. So let us divide into the concept of combinations and how it differs from permutations by the end of this session. Yes. So you will able to solve the problems related to selecting atoms from a set under various conditions. So look at here first the definition of a combination. So until now we are discuss the permutation. So the combination refers to the selection of elements from a set of distinct elements where the order of selection does not matter. Yes, but in permutation we are already discussed how the order of that element is matters. Yes, so let us see here the example how the combination is differ from permutation. If you consider the 5 letters A, B, C, D and E, and the number of different ways to do so is the combination problem. Yes, just we have to select the letters from these 5 letters, so that selection does not matters the order. Yes, that's why we can see here how combinations differ from permutation. Before that we will see here the definition of a permutation. So let S be the set of n elements S1, S2 up to Sn, yes, and T with the set of R elements, which is a subset of S. Obviously R is less than or equals to n. Then the subset T is called the combination of R elements which are taken out from n elements. So are you understand how mathematically we can define the concept of combination? We can take one set S with n elements and we can take another set T with R elements, means T is the subset of S. Yes, so T is the selection from the set S, and that's why T is called as a combination of R elements taken out from n elements. Yes, now look at the previous example. We have considered the 4 letters. So the number of ways to choose the R elements from set of n elements, and it is denoted by NCR. So already we are denoted the permutation by NPR. Yes, so this is the NCR. So NCR is equals to n factorial divided by R factorial in bracket n minus R factorial. So for the given example we are discuss here, it is we can take the set which contains the 5 letters A, B, C, D, E. Yes, it means that from the above formula we will compare it with our set. We get the value of n is 5 and the value of R is 3. Yes, so by using the above result we can easily find out the number of combinations of 3 letters which are taken out from these 5 letters. Yes, so you can put just only n is equals to 5 and R is equals to 3 in your this result, this formula. So see, this is a very just you can simplify it. 5C3 means you can take or choose 3 letters from 5 letters. So which is equals to, just you can put these n is equals to 5 and R is equals to 3 in your formula. We get the answer is 10. It means that there are 10 possible selections out of 5 letters, and it is given here. It is A, B, C. This is the one selection. A, B, D, A, B, E, A, C, D, A, C, E, A, D, E, and so on. So look at on the screen. Already I have presented here. Yes. So I think you are understand very well how the combination is differs from permutation. Yes. So see, now the above result NCR is equals to n factorial divided by r factorial in the bracket n minus r factorial. That result we have to prove here. So in the next is we have to prove the same result, and we are stated above. Prove that the number of ways to choose the r elements taken out from a set of n elements, and it is given by n factorial divided by r factorial into n minus r factorial. So how to prove this one? Any idea how to prove this one? Just you have to apply the definition of the combination. So you know the number of ways to choose the r elements from a set of n elements, and it is denoted by NCR. Yes. So the number of ways to arrange these r elements out of n elements by you know the definition of a permutation. You can write it as NPR is equals to n factorial divided by n minus r factorial. So you know this is the definition. Yes. So however, in the combination the order of selection is not matter, and that's why every distinct set of r elements can be arranging how many ways? R factorial ways. Yes. So but all these arrangements corresponds to the same combination. So to account this, we divide the number of permutations by r factorial, because they elements are not overlap. Yes, that's why we can divide it by r factorial. So the required formula for the combination is here NCR is equals to NPR divided by, you can divide it by r factorial, and after that just you can simplify it, apply the definition of a permutation. We get the formula is n factorial upon n minus r factorial, and then you can just simplify, we get n factorial upon r factorial into n minus r factorial. So this is the result we will prove here. Yes, and it is the formula for finding the selection or finding the combinations of the elements. So see here the one remark which is on again the same result. So if you put r is equals to 0, what happens? So the combination of n elements, if 0 elements are selected, then NC0 is equals to 1. Yes. The second remark is, if you put r is equals to n, then you know we have to select n elements from n elements, and that's why NCN is equals to 1. Yes. And see here the last one. What is the value of NCN minus r? So obviously it is n factorial upon r factorial into n minus r factorial. Why? Because the number of combinations of n elements taken r at a time, it is equals to the number of combinations of n elements taken out from n minus r at the time, and therefore NCR is equals to NCN minus r. Yes. So this is all these are remarks which are on that theorem. Now let us see here one example we will prove here, or result this one. Prove that NCR minus 1 plus NCR is equals to n plus 1 CR. So this is a very obvious result. Just you have to apply the definition of a combination, take the left hand side and prove that it is in the right hand side. So how? So you can take the left hand side, means left hand side is equals to NCR minus 1 plus NCR, and then you can apply the definition of a combination. We get, just you can apply. So let us see on the screen, n factorial upon r minus 1 factorial in another bracket n minus r plus 1 factorial, plus again apply the definition of a combination. We get n factorial upon r factorial into n minus r factorial, and after that you can simplify it. So in the third term, it is a simplified term is n factorial upon r minus 1 factorial into another bracket n minus r factorial. You can take the common from these two terms. So in the bracket, it is a remaining n minus r plus 1 by r. Yes. So after the simplification, if we observe, the right hand side is n plus 1 CR. Yes. So let us see here one remark. Similarly, we can prove that the following result using the same method. It means that you can prove this result n minus 1 CR minus 1 plus n minus 1 CR is equals to NCR. Yes. So let us see here the next example. Now in this example the ratio is given. NCR is as to NCR plus 1 as to NCR plus 2. It is equals to 8 as to 3 as to 1. And the question is, we have to find the value of N and R. Yes. So here the ratio is given. It means that NCR divided by NCR plus 1 is given and it is 8 by 3. So in the example, you can write NCR divided by NCR plus 1. It is equals to, just you can apply the definition of a combination. We get n factorial divided by r factorial in bracket n minus r factorial. Again, you can apply the same definition of a combination in the denominator. Yes. So n factorial divided by r plus 1 factorial in another bracket n minus r minus 1 factorial. Just you can simplify. We get the right hand side of your example and it is r plus 1 upon n minus r. Means that is the result. Just you have to compare that result with your ratio. It is given and it is 8 by 3. So this implies that, just you can simplify it. So we get the equation 8n minus 11r minus 3 is equals to 0. So you can call this as equation number 1. Similarly, you can find the ratio of NCR plus 1 divided by NCR plus 2. Yes. And that ratio is, just you can simplify it, which is equals to r plus 2 divided by n minus r minus 1. Again, in the example, this ratio is also given and it is 3 by 1. Yes. So once you can put that ratio with your right hand side, it means that r plus 2 divided by n minus r minus 1 is equals to 3 by 1. And after simplification, we get the second equation. We can call it as a second equation, and it is a 3 minus 4r, sorry, 3n minus 4r minus 5 is equals to 0. So after that, you can solve these equation number 1 and 2 for n and r. We get the value of n and r. Yes. So these are the values of n and r where the given ratio is satisfied. Yes. So this is the example to find, just you can apply the definition of a combination and we get the desired result. Now let us see here the next example. So there are 10 students player in a school, out of which 4 are cricket player, 3 are basketball player and 3 are hockey players. So the school principal wants to form a committee of 5 students player, which must contains at least 1 cricket player and at least 1 basketball player. So how many different committees can be formed? So I think you can read carefully. We will pause this lecture here. Just you can read. There are 10 students are in a school. Out of these 10 students, 4 are cricket player, 3 are basketball players and 3 are hockey players. So what we have to do here? We have to find out the different committees, but the condition is given here, and the condition is, in that committee at least 1 is a cricket player and at least 1 is basketball player is included. Yes. So how to find the solution of this example? So first you can find the total number of possible committees. Yes, without any condition. So how to do it? Just you can apply the definition of a combination. We get the total number of possible committees. It means that there are 10 players are there, out of which we have to select the 5 players. Yes. So the total possible committees are 10C5. Just you can apply the definition, or you can use the result n factorial upon r factorial into n minus r factorial. We get the total possible committees is equals to 252. Yes. So after that, we have to find the number of ways to form a committee of 5 players that does not include at least one cricket player or one basketball player as follows. So no cricket player, it means that this is the case we select the 5 players, yes, from remaining 6 players. Why we can select these players from remaining 6 players? Because the case is no cricket player and there are already, how many cricket players are there? Yes, 4 cricket players are there. That's why we can remove it and find the committees with no cricket player, and it is equals to 6C 5 ways, and it is equals to 6. Yes. So the second case is no basketball player. Means we have to form the committee of 5 players out of 7 players. Why? Because the 4 cricket players and 3 hockey players. The restriction is no basket player is included in this committee. So the committee with no basket player is 7C5. So just you can simplify, we get the answer is 21. So what we do now? So once you can find the committees of no cricket player and the committees of no basket player is included, after that forming a committee of 5 players without including both cricket and basketball players is impossible. Why? Because only there are 3 hockey players are remaining. Yes. So that's why there is no need to consider this case of no hockey player. Yes. And after that your desired result is here. The total number of 5 players committees that contains at least 1 cricket player and at least 1 basketball player is given by total number of valid committees equals to the total number of committees minus committees with no cricket player plus committees with no basketball player, and already you can calculate all these things. We get 225. Yes, it means that there are 225 committees that can be formed, each consisting of 5 players with at least 1 cricket player and 1 basketball player. Yes. So this is the example we will solve by using the concept of combination. So let us summarize now the above lecture. What we learn here? We learn first we discuss here the definition of a combination and how combination is a differ from permutation. After that we have proved the result of n factorial upon r factorial into n minus r factorial, and then we have solved 2 examples on this concept. Yes. So we will stop here.